Okay, I think it's recording.
Okay, very good.
And he got his PhD from Istanbul Medipol University in the Department of Electrical and Electronics Engineering. And then in 2018, but before, Hocam, you have been in University of Qatar in the Department of Electrical and Computer Engineering at Texas A&M University at Qatar as a research assistant with the Wireless Research Group, TAMUK. And he has 7 patents, more than 15 papers, maybe more than now 18 proceedings, and 7 book chapters. And he's working as an assistant professor in our university at our department, arkadaşlar. So please welcome Cihat Hoca. Yes.
So thank you very much for this nice introduction. So everybody can see my screen here.
Yes, Hocam, we can see your screen.
Very great. So let me put it in the presentation mode and get started. So welcome everybody to my lecture titled Electrical and Computer Engineering Directions and the Future Projections for the New Coming Engineers. So this is a talk to future engineers, and the slogan of this talk is as follows: the world is changing, and this is a call for action to get prepared for what's coming. So the outline of this presentation is going to be structured as follows. First, I'm gonna briefly explain to you the engineering meaning, then the electrical, electronic and computer engineering, why this field is so important and so critical, and what are the opportunities that you can find in it. Then we will give just a brief introduction about the classical and conventional topics of ECE, which stands for Electrical Computer Engineering. Then we will focus and give most of the attention in this talk to the new emerging topics in ECE. What are these emerging topics, and why we should care about them, and why they are important, and what are the applications of these emerging topics and the new exciting opportunities for engineers like you. Where can you learn about these emerging topics? We'll tell you where, and then we will discuss skills needed in engineering, whether soft skills or hard skills, and why these skills are really important and you have to start preparing for them from now. How do you prepare to become an excellent engineer? You know, excellent is always exceptional. So if you aim for something, don't aim to become an average. You have to be an excellent, you have to be an expert, you have to be really, really deep in your domain. Now, and then we will move on and talk about in whatever topic you want to be an expert at in the future. Do you want to be an employee engineer or an entrepreneur engineer? What are the advantages and disadvantages, the differences, and the future opportunities for you? And at the end of the presentation, I will give you some related resources that are going to be really helpful and useful for you to make your mind and to prepare for what's coming in the future. So starting with the definition and meaning of engineering. So if you just search on Google and just learn about engineering and the meaning of it, it's basically the application of science and mathematics by which the properties of matter and the resources of nature are made useful to people. Other people may say it's the design and manufacture of complex products that are useful and helpful to people. But the most convincing and most meaningful definition is this: engineering is meant to create value. So engineers are responsible for creating value to people by solving problems. So your basic role is to solve problems in better and different ways. That makes them, your solution will become described as SIFs. What do we mean by SIFs? SIFs means that your product or solution is cheaper than the other products existing in the market by certain X margin, or E, which stands for easier. So we have cheaper, easier, faster, and simpler. So this is the fifth term. So this is the responsibility of engineer. Once you create something like this, then you are adding value to the society, to the community, to the company, and people want to work with you and want to get your product. So focus on this term SIFs and never forget it. Your goal as an engineer is to create solutions for a problem that can have any of these characteristics: cheaper or easier or faster or simpler. Just look around you and search for any problem. Look at the problems that people always complain about. Just pick one of them and see how you can make this problem either easier for people. Just introduce a product or a software or a hardware device or whatever that can make the process easier or faster or simpler or cheaper. Then you have a product, you have a company, you have a startup, you have people will hire you, people will want to work with you. So that's what do we mean by engineering. So at the end of the day, engineer, one who practices engineering and who tries to achieve the above three meanings for engineering. Now let's move. So engineering is huge domain, and there are many fields of engineering: civil, electronic, electrical, computer, mechanical, mechatronics, architecture. But most importantly, we are concerned and focused here on electrical engineering. Why electrical engineering is so different and unique and has so promising applications. And what's the definition of electrical engineering first? Electrical engineering basically deals with the applications of electricity, electronics, and electromagnetism. It covers a range of subtopics, including power engineering, optics engineering, RF engineering, electromagnetic engineering, electronics engineering, control engineering, signal, speech, image, video processing. You have signal processing, speech processing, image processing, video processing. All these are on high demand. You have telecommunications, you have computing. Now, all these are subdomains and subfields that most universities around the world teach, and they prepare students for those domains and for those topics because they have already established industry in the market. So example of these domains, you have the biomedical engineering is a subdomain of the electrical engineering. So you please focus with me on these, how many topics that electrical engineering here covers. It covers so many topics, like these are the topics that are covered by electrical engineering. And it's huge, it's massive. Each one of these topics, you cannot be an expert in all of them, of course. Each one of these topics is a domain by itself, and you can be an engineer of that domain. Like, for example, you can be a telecommunication engineer, you can be a computing engineer, you can be a processing, an RF, an electronic. It's a huge, massive domain. To a level that if somebody tells you what's your profession, what's your domain, you cannot say I am an electrical engineer anymore, because electrical engineer is huge. You have to be more specific. So you can say I'm a telecommunication expert, I'm an electronic expert, I'm a power optics, laser expert, RF expert, computing, whatever, but you cannot anymore say I'm electrical engineering because it's confusing. Electrical engineering is so huge, so big, it has so many domains, and you cannot, as if you don't give any information to the body who's asking you what's your field. So focus on these domains. These are the traditional, these are the conventional subdomains of electrical engineering. So now I will give you just example of these subdomains and explain what they are doing. The first example is biomedical engineering. Biomedical engineering is the application of engineering principles and techniques to the medical field. So basically, you get the concepts of electrical engineering and the methods and the techniques and the concepts you learn there, and you apply them specifically and directly to the medical field. It combines the design and the problem-solving skills of engineering with medical and biological sciences to improve healthcare diagnosis and treatment. This is the main goal of biomedical engineering. So basically, biomedical engineering is a subdomain of electrical engineering. And it has become an independent branch recently in some big universities. We have the aerospace engineering. is the branch of engineering behind the design, construction, and science of aircraft and spacecraft. It's the same sub-branch of electrical engineering as well, and it has some connection with the mechanical as well. The software engineering is also, some people might say, oh, computer is different than electrical, but basically computer was a sub-branch of electrical engineering. It's really sub-domain of electrical engineering, but because computer has become so big and so huge, and within it there are hundreds, even hundreds of fields and hundreds of domains and hundreds of subtopics. That's why computer engineering now we can see it's an independent branch. Like back before 10 years when I was working in a university, the name of the department was electrical and computer engineering. But now we can see nowadays that they separate them because they have become really big. By their own, they have a domain, and they really literally say that it's not so related nowadays to electrical engineering. But basically, software engineering is part of electrical engineering. But because it has become so big, it got separated now, and people think that it's something else. Or the electrical engineers, especially, sometimes they think, I don't need to be a software engineer. I don't need to be an excellent in programming. I don't need to be aware of all these all these softwares and how to use them, and all these programming languages that help us solve the problems and automate the solutions in a nice way. But the fact is that you need this. Whatever your major inside the electrical engineering, without the programming, you will not be a good engineer. Wherever you go, wherever you apply, wherever anything you want to do, coding is like writing. If you don't know how to code, as if you don't know how to write. So it's very important that you understand the concept of coding, programming, dealing with machines, letting machines understand your instructions, and execute things and implement things. Because sometimes we have ideas, we want to execute them, we want to implement them, but without a tool, a programming tool that enables us to do this, we won't be able to apply or to implement or get a product out of these ideas. So it's very critical that all of you, all electrical engineers, to be very good in programming. Don't say it's not my major, it's not my domain. Even if you don't take too many courses in programming, it's your major, it's your domain. You need to work on yourself and prepare for this, because it helps you create amazing products. And really, when you say I know Python, I know how to code in C#, C++, Java, MATLAB, you increase the probability of being employed at companies. And those, don't get scared when you hear different languages. They have the same concept of programming. The only difference is the syntax. As long as you are familiar with the concept of programming, all these different languages, you can learn them in a day. One day, yes, one day. Don't believe me, just try it. As long as you have the basics of just one programming language, you know how it works, then you can quickly learn any language. But you just need to change the syntax. You read it in one document and adapt, and while you are executing the project or doing a certain task, you will be learning more and more. So we call this process learning by doing. The same with systems engineering. You integrate different systems, you try to make them work with each other. The focuses on the integration of electrical, mechanical, software engineering systems. That's also a subfield of electrical engineering. And we have the engineering related to, the vehicles, the auto vehicles, the airplanes, and many of these stuff that's really important and related to our life. And electrical engineers are always involved in all these prototypes and all these designs, and in the manufacturing process of most of these cars and airplanes and lorries and so on and so forth. We have the RF engineering, which is responsible for the architecture, analysis, design, modeling, verification, technical evaluation, and selection of hardware related to RF system to make sure that the components can coexist with each other. and you make sure there are no problems and no interference and everything in control, especially when you are designing chips inside your computers and sensitive RF components. Now, up until now, we have discussed the conventional fields or subfields, subtopics of electrical engineering. But what are the new emerging ECE related technologies? What are the new emerging, let's say, engineering fields that still you cannot find independent departments inside universities teaching these fields, because they are very new, very recent, but very hot topics, and they are very useful, and most of the companies around the world are using them in their products or in their processes or in their manufacturing industry factories. So the following topics that I will be giving you a glimpse about them are really important, and the industry is moving towards them, and you cannot escape them. If you want to be employable in the future, if you want to have a good company in the future, you need to work on any of these topics. So the first topic is blockchain technologies and digital currencies. You know, blockchain technology, the basic principle behind it is to be able to build distributed applications, which has no central control power, which means that the users can directly communicate with each other and they transmit and receive without being controlled by any middleman. So all these applications that you see in the internet, they have a manager, they have a central, they have an admin. Yes, let's say Facebook, you are using Facebook. So Facebook can block your account at any time the Facebook company wants. Yes, if you have recently heard, like if, for example, Twitter, they blocked President Trump tweets. Yes, they removed them. Why? Because Twitter is a centralized application, which means the control of the application, the control of the platform is in the hand of the company that created that application. But so at the end of the day, they have full control on removing your messages, removing you from the platform, blocking you, whatever. But the future of blockchain is to make technologies and applications that have no one who has full control on them. So just the users who are using them. So nobody can take anybody out, nobody can block anybody. You understand me? So this is one of the nice applications of this digital blockchain technology is the digital currencies. We have the Bitcoin, the Ethereum, and we have in several countries, the governments are working on producing their own digital currencies, but those currencies will be under the control of the government and the central bank, but they get the advantages of digital transaction, and you get the advantages of blockchain technology, but in under control manner. So this field is really emerging, and many jobs are opening every day about opportunities in this domain. So it's one of the critical fields that people and future engineers should be looking at, especially when you are studying, when you are during your 4 years of study, during your summer, instead of just wasting your time or not working on yourself and developing. You can just learn about blockchain. Yes, in our universities we don't have courses about blockchain because it's a new technology and it's not part of the curriculum, because it takes time. You know, it takes time until these new emerging technologies get involved and in our curriculum and our system. So it takes time. So don't wait for this. Just develop yourself by yourself during these 4 years. The second big thing here, the Internet of Things technologies. This is so big and so important and so critical that I myself, one of my courses that I teach the student about, I give the course of Introduction to Telecommunication. So at the beginning of the course, the first few months, like 2 months, I quickly just cover all the topics, the fundamental topics of the Introduction to Telecommunication, and then I teach my students about Internet of Things. Although it's not part of the syllabus, I shouldn't be, but because it's so important, it's so critical, and we have to teach the students and prepare them for this future. So what's the Internet of Things? We will explain it in the coming slides. We have the AI, the machine learning, the artificial intelligence, the natural language processing technologies, which is related to data science. Also, it's an emerging field. We have the wireless telecom technologies, 5G, 6G, and beyond. We have the cloud technologies. Nowadays, we have cloud engineers. We have the wireless bioresonance. But wireless bioresonance is something that you can treat people by sending signals to them instead of giving them chemical medicines. Chemical medicines, they just treat the symptoms. They don't kill the roots of the disease or the root of the illness. So this is amazing. This is groundbreaking and new technology. We have the wireless remote sensing. You know, if someone wants to measure your your heart rates or breath rate or blood pressure or whatever, they have to put sensors in your body and measure these metrics. But nowadays we don't need to put anything on the body of the human. We can just remotely sense these parameters using wireless signals without letting anything touch your body. It's amazing. It's like magic. Nobody would believe that this can be possible. We have the cybersecurity domain, which is extremely huge and extremely important. And there are many jobs opening every month for security engineers, for top security experts. It's part of the electrical engineering umbrella, but sometimes you graduate and you don't know anything about it, and you found out later in the market that they demand people who are expert in security. So please prepare yourself. Whatever topic, you cannot be master of all these topics. You just pick one and you try to develop yourself in it. We have the robotics and the drone technologies. We all see many companies nowadays are developing autonomous drones which can autonomously fly and autonomously take action and even fight in the battlefield and make use of it for many civil applications as well. So the world is changing. There are new things emerging. We have the automation and self-control using machine learning and artificial intelligence that make things think like a human. You don't need to program them and tell them, if this happens, do this or execute this. Those are automatically can be, those devices or machine can automatically take actions by their own because they have the capability of learning by experience and taking inputs and output and optimize it and so on and so forth. We have the virtual reality, the augmented reality, the mixed reality, and so it's a huge field as well and very rapidly changing. And people, usually students graduate and they are not equipped, they have no idea about this. You have to be aware that these technologies exist and just look at which technology you want to be and just learn a little bit about it. Don't be oblivious to the development in this domain. We have the haptics and creating new senses to humans. What do we mean by this? This means that you can send signals to your brain through your skin by just attaching a wearable device to your skin. You can, for example, make a deaf person hear things by just sending signals through his skin. So let's say there is a deaf person who cannot hear what you say, but when you say something, this device on your head will resonate and take the sound, convert the sound and embed it inside your body and take the signal until your brain, and the brain will analyze it and understand the word. Imagine this. This is magic. This is unbelievable. I have a student who we are writing together a patent with him, who was able, he said, like, there is a problem that most people suffer from, is that sometimes you want to memorize something forever. You don't want to forget it. And usually how the human brain works is that you memorize something today. If you don't revise it after 1 week, you will like forget half of it. If you don't revise it after 1 month, you forget more than half. If you don't revise it after 1 year, you almost forget everything. So how can we solve this problem? How can you memorize something forever? How you can not forget it at all? So he designed a device, a simple device that you can put in on your skin, on your hand, and basically it just if he wants you to memorize certain topics or certain articles, he just write the article and send it as signals inside your skin, and these signals go through your whole body and reach your brain and get stored there. So you basically don't read the signal, don't see, it's just a signal embedded, transmitted, and you store it, and the brain will understand it, learn it, and store it. And this process gets repeated automatically so that the brain doesn't forget it, and it remains there for any time you want. So we have the smart web and mobile applications. It's already emerging, and this is, we all know, but now we have the smart web. We have the smart mobile applications, which integrate AI and machine learning and the blockchain technology and cloud technologies. Like the ultimate goal, the end goal of these applications, along with developing advanced mobile and wearable devices, is to have devices that are so small that can fit in the finger, in your finger, and basically all the processing, all the RAM, the processing, the computing power, all these capabilities will be hosted in the cloud. And since you will have a very high speed internet connection, you will be able to run these applications smoothly and nicely without even the need to have huge RAM or huge processing power at your device. One of the problems that most mobile phone users complain about is that after a while, let's say you buy a phone now, and after 1 or 2 years, your memory will run out and your phone will become slow, and then you need to replace it by another, because you need a phone with larger memory or larger processing capabilities. But this is for now, but in the future this will not be the case at all. You will have new devices that don't need memory at all. You don't need memory. Everything on the cloud, everything on the internet, you don't store it at your device at all. All what you need, you just request it, and the cloud, the servers will display it to you. And this display, it doesn't need to be a display of a normal smartphone. It can be a display on the air. You just convert any surface around you to a screen of any size you want. It's not limited to the physical size of your mobile phone anymore. So all these are exciting applications, exciting topics, exciting fields that are related to electrical engineering. And we don't want you to graduate and you are not familiar with at least one or two of these. And the ultimate goal is that I hope some of you might love at least and get interested in one of these topics, and he decide to be a master of it. He decide to be developing products related to it, or opening a company, or getting prepared for a good job in the future. But these are the emerging topics. These are the new things. Now, the Internet of Things. Let me just give you a brief description of some of these. Not all of them. Let's just focus on some of these. The Internet of Things. If you just search on the Internet and write Internet of Things, what's Internet of Things? The Internet of Things describes the network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data between devices. Now, let's look at this fact. Now, up until now, we have been designing communication systems and computing systems for humans to talk with each other and to exchange information and to connect with the world and explore the world via the internet, isn't it? So the communication was just for humans, for people who are conscious, who can really read, write, interact, take decisions. But right now, the move is towards objects. You want the objects to be as smart as the human. How can you make the objects as smart as the human? So what are the two distinctive things that the human has? He has a brain to think, and he has senses, he has inputs. So the senses are the seeing and hearing and touching and whatever. And the brain processes information, understands patterns, and analyzes things and take decisions. So with the Internet of Things, you are basically putting senses to these devices and programming them in such a way they take action when something happens remotely. So you basically combine, you give these objects, you give these dummy things, which are to us, they are stupid, they have no intelligence whatsoever. For example, let's say we want to make a smart fridge or a smart a smart coffee machine or a smart table or a smart window. Imagine you are making a smart curtain. So how can you make this smart? You give this object, you give it three things. We call it triple C. What are these triple C's? We give it computation capabilities, communication capabilities, and control capabilities. So the communication is to be able to send and receive information and take action when something happens. Send notification, send information, receive information, take action. This is the purpose of communication. The purpose of computing is to process things and take and send comments, receive comments, and understand them, analyze them. The purpose of control is to take action when something needed. For example, the object will be integrated with a, let's say, a microcontroller, most often like ESP32 or Arduino or whatever, something like this. And when something happens, according to your programming, you can instruct the microcontroller to activate one of its outputs, which is connected, for example, with a notification message to be sent to the mobile phone, or by the activation of a call, or activation of a microphone or a sensor or whatever. The applications are unlimited, and it's up to you, to your thinking and your creativity and what you want to build and what you want to do. So this is basically the Internet of Things. It's it's domain agnostic. What do we mean by domain agnostic? Domain independent. You don't need to be a computer engineer or an electrical engineer to make use of the Internet of Things. It can apply anywhere, to any domain, anything. So anybody who makes use of this will benefit his field or his application. So example of Internet of Things projects that I usually do with my students in my course of Introduction to Communication. You can find them in this link, this presentation. I will share it with you, and you can check these nice applications, nice projects that my students built during their third year, before even their graduation project. Now, some of the students do really very well. Some, if they are not interested, they don't do very great projects. But in overall, this gives you exposure to what's possible to be done. Many of the students, they were able even to sell their products for people who are interested in them. So this, you can click the link and maybe visit these demos and these projects that we hope you can make projects better than them in the future. So we have the artificial intelligence now. What's artificial intelligence? It refers to the simulation of human intelligence. You want the machine, you want the computer to think like a human, to be smart as a human. What's unique about this? The machine will take decision and will take action by itself. You don't need to explicitly programming and tell it what to do exactly. It just learns, takes action according to the environment and what's happening. So simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term may also be applied to any machine that exhibits traits associated with a human mind, such as learning and problem solving. And this is very exciting domain, especially when you combine it and integrate it with the Internet of Things. Now, where you can learn these and how you can get started with these domains. For example, one of the nice websites I found on the internet, which is really useful and helpful to get you started in these, is called researcherstore.com. You can find it when I share the presentation. You just need to here type courses, /courses, and write here blockchain. For example, you want to learn about blockchain, and you will find many courses here. You want to learn about something else. Let's say you want to learn about about artificial intelligence, you just write artificial intelligence and you get several courses. You want to learn about 5G, you write about 5G. About security, you write security, you get there. You learn about Internet of Things, you write Internet of Things, you get there. So what's the difference between these websites and the other websites that teach similar things? The other websites, the problem with them, whenever you want to learn a course or this, you need to buy it or this or that. This platform gives you membership, access to all the courses, and you have full access to all of them and learn anything you want, any domain, and with just one membership level. You don't need to keep paying for different courses and different tests. It's just membership level. You become a member and you just start learning all these things or whatever you want or see suitable. Now, we learned about these new emerging topics, which are exciting and amazing and useful and are going to change the world around us. And we want to learn, we know where to learn about them now. We want to know what are the emerging applications related to these technologies. So what can we do with these technologies? First, we have a new domain called now Fintech. What's Fintech? It's financial technologies. When you, for example, give me an example of this, central bank digital currencies. All governments around the world nowadays are thinking of how to move from cash society to cashless society, where everything can be, the currency, our currency can be digital. And I don't mean by digital using your credit card or this. I mean like something that's like Bitcoin, but also controlled by the government. So most of the government around the world are working on this, and they have projects right now. And for example, in China nowadays, they have the digital yuan, where anybody wants to buy their products or this, they can buy it using their own currency, which is digital. What does this mean? This means that you don't need to pay fees for transaction, to lose money while you are converting, and this is fixed value. It's like an asset. And also it means to solve the inflation problem that most countries are suffering from. And these are all these applications and all these nice use cases are enabled by blockchain technology. Once you learn about blockchain, you can get involved in these projects. You can work on developing these digital currencies or digital distributed applications or whatever. We have another domain called biotech. Example, biomedical, bioresonance, radiobiology, and so on and so forth. Basically, you combine technology with biology. And there are many exciting applications for this. We have the Agritech. You combine technology, the previous emerging technologies with the agriculture, and you make solutions that can make the process of making things safe, cheaper, easier, faster, simpler. You have the Chemitech. We have something called, as an example I'm giving here, we have something called the smart material. We have another thing called metamaterial. What do we mean by this? This is a new research domain in which you can make things invisible, for example. Yes, you design material that when you put it in a certain object, the object will not be visible to human beings. It's one of the applications. There are many as well. We have the Physitech domain, where you build smart buildings, smart infrastructure that are resilient to earthquakes, and they can move and shape according to the vibrations, and they have many features that are integrated with the nature around them. They adapt, they adjust, they are not fixed. We have the MECTech, the automechanical machines. We have the electrotech, like AI chips. We have the ARM-tech, like auto-fighting drones. We have the autotech, that's self-driving cars. We have the energy tech, like smart grids. We have also domains like system interoperability to connect these independent systems created by different groups and let them talk with each other. And many more disciplines that I didn't mention in this list, but this is to give you just a glimpse of an eye of what's possible and the exciting emerging new applications due to these enabling technologies. So we have also other disciplines and specialties like MEMS, chips, fabrication, wireless telecom, lasers, electronics, automotive, solar energy, renewable energies, batteries, motors, machines, electronic appliances, and many other disciplines that are not mentioned here. Those are just examples. Now, okay, now we know the exciting new emerging technologies that we should take care of and we should look at and learn about and prepare ourselves for. But now let's talk about the skills that are needed for engineers to be successful in these emerging technologies. These, of course, yes, you will learn the technology, but now then, I mean, is that the only thing that I need to care about, learning the technology? Of course, it's not the only thing. You need to have other skills that can complement, that can integrate with the previous skill of learning and becoming expert in one of these emerging technologies. Among these skills, you need to be really good in math. As an engineer, most of the solutions to the most difficult problems in life are generated from math. So math is so surprises us sometimes with nice solutions that we cannot find without math. So, but where is the problem? When you study math independently and just abstract math, like just course about math without learning the applications of math and the problems that math can help you solve, you will feel bored. You will not feel motivated and encouraged to learn more and be excited about and love it the way you should love it. But like math is really helpful and useful when you integrate it with real world applications and use cases to solve problems. So when you look at math, please look at it from the perspective that it can be combined with any field and help you solve problems. It's not just a boring subject that you need to learn it to just pass the grades and finish the school and then you never look back at it. As an engineer, you need to apply and deploy math in your field so that you can come up with solutions for critical problems that are really hard to solve. You need to be good in science, not only in your domain, but all have some basic understanding and basic knowledge and on some independent vertical sciences, because this allows you to borrow some of the ideas that are implemented in X science and apply it in your science to help solve certain problems. Of course, not everybody can solve these problems because they don't have the knowledge of the other domains. They don't look at what other people have solved similar problems in their domain. Once you have hybrid knowledge in 2 or 3 different domains and apply the knowledge that exists in one domain to another, you will be surprised by how many problems you will be able to solve. We have critical thinking, how to be really think. What do we mean by critical thinking? Critical thinking means like you come at something and you see that it's inefficient. So you start questioning why this is going like this, why this is happening like this, why the employees are doing things like this. Cannot we do this to improve the efficiency? Cannot we just so you start questioning things. You don't take things for granted. You question them. And the problem solving, good engineers should always love problems. Yeah, everybody hates problems. They escape from problem. They don't like to see problems, but problems are really the the job opportunity opening for engineers. If there are no problems, no need for engineers. So as an engineer, you should embrace problems, love to see problems so that it opens and it triggers your mind to come up with solutions. So the the point is that you need you need to be always listening to people and carefully analyzing their problems. Wherever there is a problem, there is an opportunity. So that's a skill that not every engineer can master, but I hope some of you can learn it and embrace it and develop it and master it. So these are the hard skills. We have the soft skills, we have the communication skills, the teamwork, the leadership quality, the creativity. All these are important. You have to be very effective communicator. You have to be good leader. You have to be able to coexist with your team to create, innovate, and all these are soft skills, not hard, but they are very critical and very important. So how do you prepare to become an excellent engineer? As we said before, by mastering the soft skills and hard skills, and these some of these two skills like math, physics, chemistry, electronics, biology, writing, English, debate and speech, working on Teams, Microsoft Office, computer presentation skills, how to convince others, how to sell your products. All these are important and the critical stuff that you need to learn and master. Now, the big question is this. In whatever topic you want to be an expert at. Yes, you choose a topic, you say, I want to be an expert in this X topic. I want to be good. I want to be excellent in, for example, machine learning, Internet of Things, blockchain. Do you want to be an employee engineer or an entrepreneur? So basically, as you can see here, most of the people after they graduate, they just write their CVs and then they start applying to companies they want to be employees. So this is 90, let's say 90% of the people go here, 90, maybe less, but like, or more, sometimes in some countries, 95% of the people go in this direction. Very few people go in the direction of entrepreneurship. Now, you can become as an engineer because you know the high-tech stuff and you are really good in these high technologies. It's in huge demand and there is a huge opportunity for you to become an entrepreneur because you know the technical stuff that's needed by the society, the community, and all what you need is to develop a nice application, a nice product that's needed by a certain group of people, and then just go and propose it to those people and you try to sell it. And if you can successfully do that, then you end up having a startup company. And this startup company, you apply for funding, you get funding, you improve it, you develop it, you become an independent business. And it can become like a very big company in the future, like Turk Telecom. Who knows? Like Facebook. Facebook was a startup by undergrad students like you, came up with a nice idea, presented it to the investors or to the people they trust, or just suggest to them, what do you think of, is it good, is it okay, can we get funding, we will work on it, we will devote our life for it. So this is how the process works. But like, let's explore the advantages and disadvantages of each route and see the differences between them. So here we have the advantages and disadvantages of employee engineer and an entrepreneur engineer. So advantages of the employee. If you want to be an employee, what are the advantages? Maybe the first advantage, you have holidays. You have in the weekend, you are not required to work. You may have holidays, you may have some leave benefits. You have guaranteed income every month. You are okay with the income that comes from your employer, usually small, just enough to make you survive so that you go back and work again. It's fixed working hours, but need to be available 24 hours for any emergency. Less responsibility. You are not responsible for other people. You are only responsible for yourself and your tasks, which are assigned to you by your boss. Now let's look at the advantages of the entrepreneur. The entrepreneur doesn't have the other previous advantages. The first advantage is independent and free from any boss, any company, anything. You are independent. You choose whatever you want to do. Second, growth in career and fulfilling your goals and aspiration. You can work on any topic you want. You can do whatever you believe in. You can implement your goals, apply them. Second, you have flexible working hours. It's up to you. You decide how much time you want to work, how much, where, and what, and from where. The ability to earn. Usually your income is not constrained by a salary or based on your hourly rate. It's up to you. It's up to the limit. The limit is the sky. You can make a product and sell it as many times as you want. You can have customers as many as you want. There is no limit. It's just the market that determines your limit. And change and exploration. You can, of course, explore in new technologies, in new domains, decide to work on some new ones. So you are the creators of your own destiny. The disadvantages of being an employee is dependency. You are always dependent on others in terms of salary or in terms of tasks and job. You are dependent on waiting for others to tell you what to do, and like sometimes the salary, this and that. Second is limited income. Your income is limited. No matter what you do, your income is usually doesn't change. If it changes very little. Limited development scope. You are just narrow-minded in just one domain. You cannot think of another domain because this is your job, this is your responsibility, and you are paid for doing this. No job security, of course, because at the end of the day, as an employee, based on the requirements of the employer and the demand, you can work, you can move. Especially engineers, usually they work on projects, and the projects at the end of the day has starting date and end date. So sometimes many engineers I saw, they keep jumping from one project to another. And the final one is regret of not pursuing your dreams. These are the disadvantages of being an employee. Now, coming to the disadvantages of entrepreneurship, first of all, stress, because you just believe in yourself so much, and you feel that there is a need for your idea, and your idea will work, and to make it work and to convert it to a product or to a successful business, you need to work really hard. So at the beginning, you don't have guaranteed income. You are working for free. Nobody's paying you. You are investing your time, energy, money. There is no boss to guide you. There is no colleagues for support. You and your team. You need to convince people with you to work for free. Just tell them, like, we have this idea. It's very great. The market is gonna like it. You need to be able to convince, and those will need to be able to sacrifice their time and money with you, because they have the option to go and work for other companies for a fixed salary. Why would we work for free for 2 years to be able to build something that's not sure to be successful? Like, for example, give you the example of Alibaba. The company is everybody knows this company, and it's so successful, and it's worth $1 trillion. But the starting of this company, there were like 30 employees. They worked for free for 3 years. They just have enough money to eat and do basic stuff in their life. They worked for free for 3 years, imagine, without getting any salary. And then when the company was successful and went public, each one of these was worth more than like $100 million. Each one of those, imagine. So are you willing to do these sacrifices for that great opportunity, for that great advantage that you will get? So most of the people, usually 90% of them, many of them, they don't want this to happen. They cannot wait for 2 or 3 years to have some income. Investment, you need to invest money, time, efforts for many years before you start earning. Long working hours at the beginning of your business. It's not like 5 days a week, it's 7 days a week. It's not just 8 hours a day, it's 18 hours a day. You just eat, sleep, and work. That's it. Nothing, no social life, nothing, for 2 years at least, to make your stuff successful. Financial instability, especially at the starting phase, of course, because you are starting, you are putting your money, you are putting the investors' money, because you don't have any customers now. Now you are building, it's time to build. Of course, then there is the risk of failing. Of course, you can build a business, you can build a product, you think it's gonna be great and this and that, and you build some assumption. But sometimes the market surprises you, and you will find out that there is no product market fit, and it's very difficult to sell the product, and sometimes you may fail. So the risk of others witnessing your failure, the risk of debt, the risk of hungry competitors, the risk of bankruptcy, it's not for the light-hearted people. So it's tough. It's tough, but the reward is great. The reward is great. Now, with respect to failure is not what you think. It's failure is not when you try and you cannot achieve your goal and you feel that you failed achieving your goal. Failure, the definition of failure is this. Failure is not to keep trying, doing things to achieve your goal. So what does this mean? So if you tried one time and you failed and you tried again, you are not a failure. In the second time you fail, you try third time, you are not a failure. You try again, you are not a failure. As long as you are trying, you are not a failure. Once you stop, if you stop, then you are a failure. This is how the entrepreneurship defines failure. It's not like one chance. Real world is not like this, because sometimes things work from the 10th time, the 20th time. Like Edison, how many times Edison created a bulb that didn't work? How many times? Thousands, I don't know, hundreds or thousands of times. But he said when they told him you failed 99 or whatever, he said, no, I discovered 99 ways that don't work. And you should have this mentality when you go to entrepreneurship. It's not the mentality of an employee. So that's it for my presentation. I hope you enjoyed it. It was resourceful and useful and gave you some insight. This is my YouTube channel. If you want to connect with me, see what I'm publishing and some recent, I discussed some emerging technologies, some stuff usually I publish. So you can connect with me here. You can check our previous students project here. And if you have any questions or any comments or any feedback, you are welcome to ask. Thank you, everybody, for your patience and for your time and for being here with us today, and wish you all the best. And I hope you become a very successful engineer, whether employee engineer or entrepreneur engineer. Thank you.